Now, the other formula that is used most frequently, and this is, honestly, I keep kind of using examples of savings account, but that's pretty misleading. This is the formula that is used in most savings account. It's compound continuous formula. And there's a little bit of a reason for that. In the previous one, like if you have a loan payment or something, then it's perfectly fine for them to say, okay, it's the end of the month. This is how much you owe us. This is how much interest was put on your account. We're going to deal with it that way. Where if you're going to a bank and you want to pull money out of your savings account, they're not going to say, oh, actually the month is in like starts again in 2 days, so you can come back and take your money then. No, they have to compound it all the time so that, well, if I go in tomorrow, I'm going to have a different interest than if I go today because I want the ability to pull out my money at any time. So that's this formula. And in fact, if you like calculus or you've seen calculus, if you've done something like that before, this is what happened if you would take the compound interest formula and made it n would go to like essentially a billion or even infinity. All of that's aside, you don't really need to know that for this class. And so what's new about this guy is we have this weird e, which we think, or at least I would think, is, oh, that has to be a variable because it's a letter. That's not true. E is actually a value. It's kind of, it falls into that fancy category that pi is. Pi is, sure, it seems like it's a weird symbol. Everyone knows, well, not everyone. A lot of people know that's the 3.14. It's actually a number. Same thing with E here. E is an actual number. I believe it's 2.12 or something around there. So if you're looking at your calculator now, I think even if you're looking at your iPhone calculator, they have this E. You might have to turn it sideways. Yeah. If you turn your iPhone calculator sideways, there is this E value. Just use that function and know that it's actually not a variable. It's basically taking 2 to some power. Okay, so let's see the two kind of standard formulas in practice. So here we have a question. We're going to compare two different investment options. We invest $1,000, and option A is I could have it compounded monthly at a rate of 7%, or I could have it compounded continuously with a rate of 6.85%. And I'm planning to invest for 6 years. So I'm going to figure out which is the better deal. And sometimes, especially in this course, maybe more than other courses, that which will be a better deal can be slightly subjective. We'll see more of that later on. But in this case, it's pretty objective. I'm going to go through, calculate both of them, and one of them is going to make more money than the other. So the first one, it's compounded monthly. When you see the compounded, the thing afterwards is going to tell you which formula you use. If it tells you yearly, monthly, daily, anything besides continuously, you're going to use the basic compound interest formula. If it says compound continuously, we're going to use that E formula that we saw on the last slide. So now I just have to identify my pieces of information and plug them into the correct spot. My principal is 8,000. My rate is 7%. So as a decimal, that's 0.07. My compounding monthly, so that's 12. And then I said that I'm going to invest for 6 years. So my T is 6. And then I'm going to just throw that into my calculator. And I find that my future value is going to be 12,120 and 84 cents. Approximately. I'm sure I mentioned this before, but maybe I haven't. If you see those squiggly equal signs, that means that I had to do some sort of rounding. So it's approximate. Okay. Now here is my compound continuous. Sometimes people call it PERT because you got the PE to the RT. Anywho, we know we're compounding continuously. I know that my rate is 6.85%. I know my time is 6 years again, and I know my principal is 8,000, same as the previous one. I change my 6.85, move the decimal over twice, I get 0.0685. Now it's important to mention, so I have 8,000, and then I want to make sure it's E to and everything above there is in my exponent. So if you are using your iPhone or your Android calculator, the order of operations I would use, and I guess this is the order of operations in general, is I would multiply my powers, 0.0685 times 6, and then I would hit the E button because that's telling my calculator that I want to take e to that value. And then I multiply by 8,000. If you have a nice graphing calculator, which is super great if you do, then when you're typing this out, you can type it exactly as you see it. Just make sure you put a parentheses around that power of 0.0685 times 6, and make sure you're actually doing caret, or I think it actually just forces the caret in the graphing calculator, if I remember correctly. But again, we'll probably talk through all of this when we're going through the in-class worksheet, so we're all on the same page. We all feel comfortable with using these formulas and using our calculator to find them, because honestly, that's where I see the mistakes in this section. And I find that my compound continuous formula is going to get me less money, $12,066.60. And so I would say option A is the better option. You probably could have guessed that based on the percentages. The compound continuous has this lower rate than the compound monthly, but I wouldn't rely on that heavily. Sometimes that can be misleading. In fact, if you made both of the percentages the same, they're not going to get the same answer because they're different formulas. So go through the process, show all the work. If you guess, I probably wouldn't even give you points on this, because that's not the point of the problem. It's to write out these formulas and figure out how to use them. Now, effective annual yield is a little bit of a weird formula. I'm not sure we'll see this on the exam. If we do, I'll mention this more on the review, but it's worth kind of talking through. So how this works is it's going to say, okay, if I'm using my compound interest formula, and let's say this auto dealership is saying, okay, we're going to compound monthly, and this is your rate, versus maybe another dealership talks only about your annual interest rate, or APR, then what this formula allows you to do, which is kind of cool, is it allows you to compare the two and say, okay, you said 6.85% monthly, and you said 6.5% APR. I don't really know what's better. Oh, I can use this formula and say, compare the two and say, oh, actually the 6.85% is better. So that's what you would use this for, is if you were trying to compare an annual rate versus a compound daily rate, you can figure it out with this formula. And so in this case, we're seeing that, okay, we have an annual rate of 5%, that would be your APR. Let's say another bank is giving you that same interest rate, but they're compounding daily. We want to figure out, oh, is that actually better that it's compounding daily? And like, how much better? And can we compare the two? So we are given this formula. We are told that it's compounding daily. So we know our rate is 5%, 0.05. We know we're compounding daily, so 365. Seems like I made an error. I actually didn't. And again, this is more of a reason why we won't see this on the exam. But for some reason, banks use 360 versus 365 when we're compounding daily. I wouldn't dock you if you use 365. I probably would use 365 as well. This is just kind of more of that real world. If you see this and maybe you're looking through a bank statement or something like that, be like, where does 360 come from? That's just kind of an industry standard of, okay, or well, sometimes it's a leap year and sometimes it's not. Let's just do this standard 360. So that's where that's coming from. That's why that's here. You can use 360 or 365. And now I plug that into my calculator. I get a decimal. But again, that's a decimal. If I want to compare percentages, I'm going to change that into a percentage rate. And now we see that my interest rate, when kind of compared, or my effective annual yield will be 5.13%. So it actually is a little bit better for me to, I mean, it's the same discount, yeah. So it's a little bit better for me to compound my interest rate daily as opposed to just once per year. But it's not that different, is another thing to take from this question. Is sure, it's better, but it's not like you're going to be getting 30% bump or something like that, as opposed to just the 0.13% bump. So this is a difficult slide. I wouldn't linger on it too long. There might be one My Math Lab question. I don't think there's going to be anything on the test. If there is, I'll go over this again slowly when we're doing a review or something